Welcome to today's session on Design Patterns Overview. In this session, we will explore the key categories of design patterns: creational, structural, and behavioral, and understand how these patterns can help improve your software design and development practices. So, what exactly are design patterns? Design patterns are reusable solutions to common problems that arise during software development. They provide best practices that have been proven to work in various scenarios, helping us write cleaner, more maintainable code. By using design patterns, we can improve code readability, make our software more flexible, and reduce complexity over time. Design patterns can be categorized into three main types: creational, structural, and behavioral. Each category addresses different aspects of software development. Creational patterns focus on the process of object creation. Structural patterns deal with how objects and classes are organized and related, and behavioral patterns help define how objects interact with each other. Let's take a closer look at these categories. Creational patterns abstract the process of object creation to make it more flexible and dynamic. Structural patterns help in composing objects and classes into larger structures, enabling more efficient organization. Lastly, behavioral patterns focus on communication between objects and the delegation of tasks, helping achieve well organized object interactions. Let's dive into the first creational pattern, the singleton pattern. The singleton pattern ensures that a class has only one instance and provides global access to it. This is useful when we want to control access to a resource like a database connection, ensuring that there's only one instance of a connection throughout the entire application. Here's a quick look at the code for the singleton pattern. As you can see, the class has a private constructor, preventing instantiation from outside the class. It also contains a static method getInstance, which checks if the instance already exists. If not, it creates one and returns it. This ensures that only one instance of the class is created, regardless of how many times the getInstance method is called. Next, we have the factory pattern. The factory pattern is used to create objects without specifying the exact class of object that will be created. It abstracts the object creation process, which helps in promoting loose coupling. This pattern allows us to create different types of objects depending on specific conditions or parameters without changing the client code that uses the factory. Let's take a look at a simple factory pattern example. Here we define an abstract button class with a render method. Then we have two concrete classes, Windows button and Mac OS button, that implement the render method differently for their respective platforms. The factory will be responsible for determining which button to create. In the next part of the factory pattern, we define the button factory class. The create button method in this class takes a string parameter OS type, and based on its value, it creates and returns either a Windows button or a Mac OS button. This demonstrates how the factory pattern helps in deciding which class to instantiate without explicitly specifying it in the client code. Design patterns are incredibly important because they provide a common vocabulary for developers. They help us solve complex design patterns in a more structured and efficient manner. By using design patterns, we adhere to best practices, which leads to more maintainable, scalable, and flexible software in the long run. In our next session, we will dive deeper into specific patterns like singleton and factory, and we will have the opportunity to implement them in real world scenarios. We will also explore more advanced patterns and how to apply them effectively in different situations. Stay tuned for more hands on practice in upcoming sessions.